Good morning. Today we're going to talk about solving quadratic equations by completing the square. So this is just another method of solving. Right? In the previous lesson, we solved by factoring, and then we also solved by graphing. Sometimes, though, we might want to use a different method because it might not be factorable. So we can use completing the square as one of those methods. We can use completing the square even if it is factorable, but you can absolutely use it if it's not factorable as well. So we'll go through an example of each of those. So let's say our first equation is this, x squared minus 4x plus 3 equals 0. Now I know in fact that that's factorable. I know there are two numbers that add to -4 and multiply to +3. Those two numbers would be -1 and -3. So if I factored this, I would have x minus 1 times x minus 3 is equal to 0. Okay, and then by my zero product property, I would set each of my factors equal to 0, and I would solve both of those equations. So here I would end up with x is 1, and here I would end up with x is 3. That's how you would solve it if you were going to factor it. Let me show you how you would solve it if you were completing the square, and you'll get the exact same answers. Okay? So here is x squared minus 4x plus 3. Completing the square simply means that I am going to create, on the left side of my equation here, I am going to create a trinomial that can be written as the square of a binomial. And that might sound like a lot of words, but I'll show you as we go. The first step is to make sure that the coefficient that's in front of x squared is 1, which it is in this case because there's nothing written there. So we're fine with that part. The second step is to move that constant term over to the other side. So you have x squared minus 4x, and I'm going to leave a space here because I'm going to be writing something in there. Okay, so since it was plus 3 on this side, I have to subtract it from both sides, and I end up with minus 3 on the other side. Now, here is the hardest part of the whole thing, and it's not that hard. Look at that middle term. Okay, you are going to take half of that value. So half of -4 is -2. I'm going to write that up here. So half of -4 is -2. And then I'm going to square that. When I square a negative number, I get a positive number. Okay, take half of the middle term and square it. And when I do that, I get 4. So I'm going to put that in that space that I left. In order to maintain equality, whatever you do to one side of your equation, you have to do to the other. So I'm going to add 4 on this side as well. That was the first big step. Now, this next part is writing this trinomial as a binomial squared. And the cool thing about that is you pretty much already know what you need to put in here. You know you have to have x, and you already know what goes here. It's this number right here. It's that when you took half of that b value, that's what goes in the parentheses. So half of -4 was -2, so that's what you put in there. -3 plus 4 would just give you 1. And now you have the square of a binomial. Now we're just going to solve for x. In order to get x, I have to take the square root of this, which means I have to take the square root of both sides, because what you do to one side of an equation, you have to do to the other. When I take the square root of something that is squared, I just get back the thing that I squared. So since I was squaring x minus 2, when I take the square root of that, I end up with just x minus 2. Because I put the square root symbol in on this side, I have to account for the possibility that it could be plus or minus, and the square root of 1 is just 1. Okay, so now I have two situations. I have x minus 2 is either 1 or x minus 2 is negative 1. And so I'm going to solve both of those. So if I add 2 to both sides here, I end up with x is equal to 3. And if I add 2 to both sides here, I end up with x is equal to 1. So you'll see I got the zeros and I ended up getting the same exact answers as I had over here when I factored it. So it works whether, if you can factor it, you can factor it. If you're not sure if you can factor it, you can always do completing the square to solve it. If you do it right, you'll always get the same answer. Now, sometimes we have problems that aren't necessarily factorable. So for example, let's say we have x squared minus 3x minus 5 is equal to 0. Okay, that's not factorable. There aren't two numbers that multiply to negative 5 and add to negative 3. So I can't factor it. So I am going to do completing the square. First thing, make sure that leading coefficient is 1, which it already is. The second step is to move that constant term over to the other side. So I'm going to leave a space. I'm going to add 5 to both sides. And now, just like I did before, I'm going to take half of that middle term and I'm going to square it. Now, people always want to put in decimals, and I promise you it's easier if you don't. Leave it in fractions. So I'm going to take that number. I have negative 3. I'm going to take half of negative 3. If I take half of negative 3, that just gives me 3 halves. Think about basic multiplication. Half of something. Of means multiply. So negative 3 times 1/2. When you multiply a fraction by a whole number or an integer, you multiply the numerators together. So that gives you negative 3 halves. Okay? So this is half of that middle term, and then I'm going to square it. When you square a fraction, square the numerator and square the denominator. Okay, so I'm going to add 9/4. And this is what always messes people up when they see fractions. Whatever you do to one side of your equation, you have to do to the other. Now, you will have, just like in the last problem, you will have the square of a binomial on this side. And you already know what goes in here. You know you have to have an x. And remember I said on the last problem, you're just taking what's in the parentheses here. You're just taking half of that middle term. So I'm just going to put negative 3 halves. Notice I am leaving everything as fractions, and you'll see why as we go through this. In order to combine these two terms, I have to have a common denominator, which means I need to multiply the 5 by 4/4. Remember, when you multiply a whole number by a fraction, just take that whole number and multiply it by the numerator of the fraction. So I end up with 20/4 plus 9/4. Okay? So now I have x minus 3 halves squared is equal to 29/4. You're going to take the square root of both sides. Remember, when you take the square root of something you squared, you just get back what you squared. So I have x minus 3 halves. Because I put the square root symbol in, I have to make sure I account for both cases, plus and minus. Now, the beauty of completing the square is that your denominator that you have over here is going to be the same denominator that you have over here. So, when you take the square root of a fraction, you're taking the square root of the numerator and the square root of the denominator. The square root of the numerator is just going to be the square root of 29. The square root of 4 is just 2. I'm going to add 3/2 to both sides of my equation. So I end up with x equals 3/2 plus or minus the square root of 29 over 2. That is completing the square when you can't factor something. If you can't factor it, you are always going to end up with some sort of radical over here in the numerator. Okay, if you can't factor it, you will always end up with a radical in your final answer in the numerator of one of those fractions. Always, always, always. This is still an answer. You still have two answers here. You have 3/2 plus square root of 29 over 2 and 3/2 minus square root of 29 over 2. That is the process for completing the square. Let me show you one more way that we use completing the square. And that is when we are trying to convert something from standard form into vertex form. So let's say you have f of x is equal to x squared plus 6x minus 16. Okay? I want to put that into vertex form. This is standard form. Remember, vertex form is this. F of x is equal to a times x minus h squared plus k. So I want to convert it from this form into this form. Here's what you're going to do. You're going to complete the square. Now, because I'm not solving for anything, I'm not moving any terms to the other side of the equation. I'm just converting the form that this is in. But I am still going to complete the square. I'm going to use these first two terms to do that. So I have x squared plus 6x, and I have minus 16 out here. Okay, so I haven't altered anything yet. Now, just like I did before, I'm going to complete the square. So I'm going to take half of this middle term. I'm going to take half of 6, which is 3, and then I'm going to square 3, and that gives me 9. So I'm going to add 9. Because I didn't move anything over to the other side of my equation, but I still need to maintain the original equation that I started with, I need to maintain the value of that original equation. Because I added 9, I now need to subtract 9. Okay? Because if I don't, then I will no longer have equality. Now, this is the square of a binomial. You already know what this is. You know you have to have an x. You already know what this second term is. It was half of that middle term. 3, and then you can combine these two terms together. And so you have f of x is equal to x plus 3 squared minus 25. And that means that your vertex is at -3, -25. Well, that's how you do completing the square. Hope that helps. We'll talk about this more next time in class tomorrow. Okay, Sebastian, take care. Thanks. Bye-bye.